What's going on, everybody? Thanks for tuning back in. Today we're going to take a look at creating a scene manager for scene transitions and moving in between levels. But before we do that, let's do a quick recap on everything we've covered so far. In the first video, we covered the project setup, where we took a look at the folder structure, where we're going to put our files, a basic script, a logger, and just getting everything started. In the second part, we took a look at how to create our first level, and that involved using tile sets, tile maps, and the tile map layer of Godot 4, which is different from the tile maps of Godot 3. In the third video, we looked at creating our player, and that included creating the player, adding all of its child nodes, doing some basic scripting for the player and for characters that will inherit the same functionality, and some movement and stuff like that. In the fourth video, we added colliders, so we actually made it so our player could interact with the map as far as collisions go. And that includes things like colliders inside of a tile map layer, the collider on a player, things like static bodies, etc. And finally, before this video, what I actually did was I reformatted the code a little bit and cleaned it up. Everything is available for you inside of the repository. You'll also notice that there's a C#ier config file in there, and that's because I'm now using that for my code formatting to keep everything looking nice for you. If you want to learn more, there's a link in the description below. Other than that, let's get back into it. So the game manager is going to be basically the starting point of our scene, of our game, and it's going to determine how everything interacts with each other. I like to have a game manager script just to kind of keep everything in place, and I can always refer back to it to know what's going on. So let's go ahead and add a script to this game manager. Now, even though this game manager is not going to be called from the globals that is inside of the project settings, I'm still going to make it a singleton because I only want one instance of my game manager to keep everything simple. That way, anything game related, I can just call back to it from any script inside of my project. Now, I'm going to go ahead and create two export categories, one for nodes and one for variables. The node that we're going to have inside here is going to be our sub viewport that we added that holds the actual scene inside of the sub viewport and the camera and whatnot. I'm going to name it game viewport. And then I'm going to have a public player underneath my export category of vars. Even though we're not going to assign the player directly from the inspector, we're just going to keep it exported so we can see it in the inspector. And I'm going to actually assign this when we change the scene. Inside of our ready function, you could go ahead and assign the instance to this. So we make this the only instance of our game manager and add a little logging statement. I'm also going to put a to-do note here, and I'm going to say change the scene when this game starts up. So right from this function is where we're going to start up the actual game by changing scene into our first level. So now we're going to create a couple functions. The first one is going to be a public static sub viewport, and I'm going to name this get game viewport. That way I can get the actual viewport from any of my classes, mainly the scene manager. And this is just going to return our instance.gameViewport. Next, we're going to make another static function that's going to return a player. And we're going to add player and then pass in a player of type player. You like that? Inside of it, we're going to do an instance.gameViewport.addChild, and we're going to pass in the player so that the player is now underneath the game viewport on the same level as our level is going to be. Next, we're going to do an instance.player is equal to the player we've passed into the function. So now that variable is assigned. And now we're going to return an instance.player. Now here you don't have to make the static function return player. You can just make it void, but I make a return player in case you want to chain stuff together. And then finally make another static class called getPlayer that just returns the instance.player variable. The next thing we can do is go back to Godot. Go ahead and go to your player and set the Z index to something like 5. 10 is what we're using to overlap the player and everything. So between 0 and 10 is where you want to be. Let's just set it to 5 to be safe. Back inside the game manager, underneath your game manager, once you rebuild, assign the game viewport variable to the sub viewport. Just drag it over. Underneath our sub viewport, we can go ahead and delete the level that's there because we're going to be loading this dynamically with our scene manager class that we're going to create. Open up the small town level or whatever your level is called. And I have my player in here as well. I'm going to get rid of that too because the player is going to be loaded dynamically as well. And then underneath my level, I'm going to create two new Node 2D objects. They're going to be called scene triggers and spawn points. I like to put a spawn point inside of each map because eventually you might have some sort of save load function and you might want to use the spawn point. If not, it's always good to have one. And the scene triggers are going to be for transitioning between scenes. So when we enter a doorway, how are we going to get there? We're going to use a scene trigger, and that will take us to the next level. Next, let's go ahead and create a script for our actual level class. So you can right click on your level and attach a script to it. And I'm going to put this inside of a levels folder inside of my gameplay folder. The level script is going to define a couple things, mainly the level name and the camera limits for the player camera so that the camera doesn't go out of bounds, and show you all the gray outside of the area you've tiled. If you don't want to do camera limits, you can just make sure you have, a forest covering all of the camera angles that you could have in the level. I like to put the boundary on the cameras. It makes it a little bit easier to manage what the actual level looks like. Inside of our level class, you can make an export category. I'm just going to call it like level vars or level basics. And here I'm going to create the level name. Now, normally this would be a string, but I just want to select it from a drop-down list inside of the editor. So let's make it an enum. So I'm going to go to my enums file inside of the core folder and add a level name enum. Inside of it, I'm going to create my public enum. I'm going to call it level name. And all of my level names I'm going to make sure are lowercase to match what my files are. If your files are uppercase or just capitalized, to make sure that it matches. But I'm just going to keep everything lowercase to make it simple. And I'm going to create a reference for my small town, and then each of the places that I want the player to enter. So in my case, I have 2 houses, a Pokemon Center, and a cave. I'm going to create a level name for each of these, and then eventually we'll assign it to each level when we create them. Once you're finished with that, go back to your level class and add your public level name and create a variable for it. And then the next export category is going to be our camera limits. So what you're going to need here is you're going to need 4 integers, top, bottom, left, and right. And these will define the limits of the player camera. So the camera can't go outside of the boundary you set up here. And then finally, inside the ready function, we can go ahead and log like we always have been. I might actually just pass in the level name here as well. Once you're back inside the editor, go ahead and rebuild the project, and then you can fill in your camera limits. So for this level for me, the top and left are going to be 0, and then the right's going to be 512, and then the bottom's going to be 320. I'm getting these numbers straight off the grid on the left and top of my editor. So I'm going to go ahead and create a new Node2D scene, and I'm going to call it spawn point, and I'm going to attach a script to it. Inside of our spawn point script, I'm going to override 2 of the Node2D virtual functions, and those are enter tree and exit tree. These functions are called when something is added to the scene tree or removed from the scene tree. If I create this spawn point in code, nothing will actually happen. These functions won't fire, specifically the enter tree function won't fire, until I use the add child function and actually attach it to something inside of my scene, and then removing it will fire exit tree. Inside of these functions, I'm going to add the add to group function and remove from group function. And inside, you're going to pass a string name of the group you want to attach or remove these from. Groups in Godot are very useful as they can group together objects for you, and you don't actually have to track them in the scene tree. You don't have to search for them through the child nodes of whatever parent class you're looking at. You can just access the groups and they're automatically listed for you. This is a very convenient way to just scan for spawn points or scene triggers. I'm going to create a new enum for this, and I'm going to create one for spawn points and for scene triggers. So let's go do that now. And then once you create those, you can pass those enums in here and then just add the toString function at the end to transform it to a string. Or you can pass it into a string as a variable. Either way, as long as the add to group is receiving a string, it doesn't care how you do it. Now I'm going to go ahead and add a spawn point to my actual small town here underneath the spawn points category inside of my scene tree. And now let's create our scene trigger. So similarly, we're going to create a new node, but this time we're going to do an area 2D, and underneath it, we're going to add a collision shape 2D. And our collision shape 2D is going to be 16 by 16. But once you've lined it up with your square, what I want you to do is actually scale it down to 0.9 so the edges aren't touching. That way, the colliders don't accidentally touch each other and there's no weird collisions. You make it a tiny bit smaller because when two colliders are side by side, they could still trigger. I don't want this to trigger until I'm actually inside the square. Go ahead and attach a new script to the scene trigger. You could put it in the same folder as your level and your spawn point. And we're going to throw this inside our namespace. And this scene trigger is going to obviously inherit area 2D, and it's going to have a couple variables. So the first export category is going to be called target scene vars. Inside of this, we're going to have a public level name, and that's going to be our target level name. And we're going to have one more variable that's an integer, and that's going to be our target level trigger. The reason why we have this integer is because certain scenes, like this small town, for example, is going to have multiple triggers, and we needed a way to tell them apart from each other. So we're just going to assign them an integer starting at 0. Similarly, we're going to create a current scene vars export category, and then we're going to assign an integer called current level trigger. So this level's trigger knows which one it is. And inside of the target scene, the current level trigger is going to line up with the target level trigger, and you'll see that in a little bit. We also need a public vector2 called entry direction. Now, this is going to be for whichever way the player comes into the scene. Basically, what we want is to spawn the player at the position of the scene trigger, but one square in the entry direction. So if you're entering a scene going up, let's say, I want the player to enter that scene on the scene trigger, but up one square. The reason we want to do this is we can't spawn it directly onto the scene trigger, or we would just keep going back and forth between levels. We want to spawn it one square in front. So we're going to need an entry direction to tell us where to spawn the player. Finally, I'm going to add a public bool called locked. If you want to lock a door, you can just have a little bool on it to stop the scene trigger from actually doing anything. So the next thing I want to do is I want to go to my spawn point, and I'm going to copy and paste my enter tree, exit tree functions and change my enum to say scene triggers. Next, we have to create a function that's going to get triggered when a collider enters this area. So we're going to make a new function called onBodyEntered, and it's going to take in a node 2D. We'll call it body. And this is actually going to be hooked up to a signal. Inside of the ready function, you can do body entered. This is a signal provided by the area 2D, and just do a plus equals the onBodyEntered function. And now this signal's hooked up, and this function will get triggered anytime a collider enters this body. Inside of the function, we're going to check to see if the body.name is not equal to player. And if it's not the player, we just want to return, because we don't want to trigger scenes from NPCs or anything that's not the player. Next, you can check to see if the door is locked. You can return right here if you want. I'm just going to log for now, just so we can see it pop up in the console. And we can change this later in a future video once we add sounds. I'm also going to put a note here, just a little to-do, and say change scene. This is where one of our scene triggers is going to go. We already put one inside of our game manager. Open Godot back up and make sure you save your scene trigger scene. And then back inside my town, I'm going to instantiate a couple of these. I'm going to put a scene trigger inside of each doorway. So I'm going to have one in each house, one in my Pokemon Center, and I'm going to have 3 on the cave. So when we're actually filling out all of the variables, you have to be careful when you're using multiple ones per map. But the house, the Pokemon Center, they should be easy. The current scene trigger is going to increment by 1 every time you add one. And the target level trigger is always going to be 0 because there's only one entrance in all 3 of these buildings. Inside of the cave, however, you're going to have 0, 1, and 2 in order that you put your scene triggers. So you have to make sure when you create those maps that the 0, 1, and 2 correspond to the proper triggers. Finally, in each one of your scene triggers, make sure that the target level name you've selected from the drop-down menu is the map that you're going to want to hit. Finally, the last thing I'm going to do as far as this overworld map goes is I'm going to copy this boundary collider over here and create a new one to block off this side of the map for now. Make sure that if you're copying static bodies that you go to your collision shape and you make sure that your rectangle shape is unique. Otherwise, every time you try and resize it, it will resize the one you copied it from as well. Once you finish creating all of your triggers, the next step is to create a bunch of maps to map out all of the different scenes you want to go to. So in my case, I'm going to have a couple of indoor houses and the Pokemon Center and a cave. All of the sprite sheets I use will be available for you in the description below and in the GitHub. With that being said, please enjoy the montage, or you can skip over to the next part of the video. All right, so I've created all of my levels. Each of them has the level script attached. I've made sure to have the right camera limits, and I've made sure to change the name of all the levels. So let's go ahead and start working on our Scene Manager class. Go ahead and create a new scene. I'm just gonna have it as a node. I'm gonna name it Scene Manager. And then underneath my Scene Manager, I'm gonna add two child nodes. The first one is gonna be a control node for UI. And once you add it, make sure that you set it to the full rect in the anchor presets, and also lock the anchors here so that whenever you resize it, it moves the anchors, not the offsets. And then underneath, we're going to add a color rect, and this is also going to be full rect, and you're going to do the same thing you did with the control node. The difference for this color rect is that we're going to set the color to be black. And finally, make sure the Z index on your control is set to something like 100, because this color rect is going to be used for fading in and out between scenes, and we always want this color rect to appear on top. Now it's time to add a script to our Scene Manager, and we're going to throw that into the core folder with the Game Manager. Now, much like the Game Manager, our Scene Manager is going to be a singleton, so we're going to make a static instance of it, doing the get and the private set. That way we can call it from any of the other scripts in our project. Next, we're going to add another static variable. It's going to be a bool, and we're going to set it to isChanging. This will also be get private set. This is what's going to track to see if we're changing scenes or not. And if we are, we'll use this to disable things like player controls. Go ahead and throw up an export category. I'm just going to call it Scene Manager Variables, and we need three variables. We need a color rect, and we're going to call that our fade rect. This is going to reference that black square that we just made under our control node. You're going to make a public level, current level. That way we can always keep track of what level we're on through the Scene Manager. And then what we're going to do is make a public array of levels and call it all levels. This array will come from Godot, not from system. Make sure you're using the correct array. Otherwise it won't show up in the inspector. The reason that we want to track all levels is the way we're going to be loading levels is we're going to actually save our levels to memory. This isn't a big deal in a smaller game like this, but if you have a large game with a lot going on, this isn't the way you should go about it. You should have some sort of abstract class or interface that helps you keep track of what was inside each level, like positioning and stuff. We don't have to worry about that, again, because it's not a big project, but just keep that in mind if you're going to use this for something larger than this. Inside of our ready function, I'm going to set the instance equal to this, and isChanging can start off as false. And you could throw a little logging message in there too, like we've been doing. So the next function we're going to create is going to be the meat of the scene changer or the Scene Manager. And we're going to call this function change level. It's going to be a public static async void. It's going to be asynchronous because we're going to want it to wait for something to happen before we perform any more actions. So it's going to take three parameters. It's going to take a level name enum, an integer that's a trigger number, and a bool that's representing whether we are spawning or using a scene trigger. I'm going to give each of these a default value, but in C# you can call each parameter individually if you want to, and I'll show you how to do that after. So the first thing we're going to want to do inside of this function is we're going to want to wait to see if we're changing a scene already or not. We're going to use a while loop to wait for is changing to equal false. Once is changing is equal to false, we'll know that the change level has finished and we can start it up again if we need to. So how we're going to do that is we're going to do a while loop, set it to is changing. So it's just checking to see if the bool is true or false. And inside of it, we're going to wait for a signal to get processed. And what we're going to do is we're going to await our instance.toSignal. And we're going to do our instance.getTree. So it's just going to get the whole tree. And then we're going to wait for a signal called process frame. This process frame is kicked off every frame at the, believe it's at the end. And basically what we're doing is just waiting for a frame to go by and then checking to see if our bool is true or false. Once it is false, then outside of it, we can start our function. So right outside of it, we're going to actually change is changing back to true because now we want this to lock basically. So we can't trigger change level again in the middle of a scene transition. The best way to look at the is changing variable is to consider it like a locking mechanism. Now, the first thing we're going to have to do is we're going to actually have to get our level. So we're going to either check to see if the level exists inside of our all levels array, or if we have to load it. So we're going to create a new function. It's going to be a public async task get level. It's going to take one parameter, and that is our level name enum. Inside of it, we're going to want to check to see if the current level is not equal to null. So we're actually on a level already. We're going to want to fade the screen out. So we actually have to create two more tasks to handle fading out and fading in. And what we're going to do is we're going to create two functions, and they're also going to be async tasks. One is going to be called fade out. One is going to be called fade in. They're going to look very similar. Inside of it, you're going to create a new variable called a tween, and that's going to be equal to create tween. And to tween a property means to adjust it over a certain period of time. And what we want to adjust is our fade rext color, and specifically, I believe it's the A variable, which is its transparency. So how we do that is we do tween.tween property, pass in our fade rect, pass in color :A. We'll do 1.0 because we want it to be non-transparent, and we want it to take 0.25 seconds. And then at the end of this function, we're going to await toSignal, and we're going to pass in our tween, and we're going to wait for the tween signal of finished. Once it's finished, we know the fade out is done. We're going to copy and paste this function basically for fade in. And instead of 1.0, you're just going to do 0.0, which basically means make it transparent again over this amount of time. Go back to the get level function, and inside of your if statement, you can do an await instance.fadeout. So if the current level is there, the screen will fade out, and then we can handle switching the scene to the new scene. Next, what we want to do is we want to make our current level equal to all levels dot, and then we're going to use the first or default function. And we're going to search for our level by our level name. So basically you want to check to see inside of it, if the level.level name is equal to our level name parameter, then we're good to go. But if this first or default returns null, it means that we haven't actually loaded this level yet. So we're going to have to grab it from a pack scene. If current level is an object, then we already know that we have it, and we could just add it back to our scene tree. This is how we're going to keep track of the different states of the level, as we're just saving them to memory for now. Create an if-else block if the current level is not equal to null, so all levels return something. Then you could just do your game manager.getGameViewport and then add the child, which is the current level. If it is equal to null, then we actually have to load it. So how we're going to do that is we're going to do a gd.load. You're going to pass in the packed scene as a generic type. Using Godot's the res : syntax, you're going to do the scenes levels, and then you're going to pass in your level name. And then you're going to continue the string after and do a .tscn, which is the scene type. And then after that, you're going to call .instantiate and then pass in the level class as your generic type as a function. Basically what this will do is load the level and then instantiate it for you. And then all that's left is to add it to our all levels array. So you do all levels.add, and then add it to the game manager.getGameViewport like we did inside the previous block. So now the levels loading is going to be handled. So the next thing we have to do is figure out, are we spawning the player or is this switching the player's position because this is a scene trigger? So first let's make a public void spawn function and handle spawning the player for the first time. So inside of our spawn function, we're going to create a variable called spawn points, and that's going to be equal to our current level dot get tree. And then we're going to do get nodes in group, and we're going to search for the spawn points group like we did inside of the enter tree, exit tree functions. Then let's check to see if our spawn points dot count is less than or equal to 0, then throw an exception here saying we're missing spawn points and we got to come fix it. Next, create a variable called spawn point and make that equal to the first index of the spawn points array and just cast it to a spawn point class. We don't really care if there's more than one. I just want to use the first one for now. Next, what we're going to do is instantiate the player. So similar to the current level, you're going to create a var player, and that's going to be a gd.load. You're going to do a pack scene. You're going to enter the address of the player scene, and then you're going to do a dot instantiate with the player as the generic type. Next, you're going to do a game manager dot add player and pass in the player that we just created. Now this add player function actually returns that same player. So you could just do dot position equals spawn point dot position here. But I'm also going to show you that get player function we made and do a game manager dot get player dot position instead, just to show you that they both work. But you could just make it one line because we chained it with the add player returning the actual player. So you can do either or. That's all we need for the spawn function. So now let's create our switch function. The switch function is going to take one parameter, and that's going to be the trigger. So what we want to do is look for the trigger that we're trying to spawn to inside the map. So if you have multiple triggers in a scene, you want to make sure you get the right one. Similarly to the spawn points, we're going to grab our scene triggers the same way. So you can just copy and paste that and change spawn points to scene triggers. And then same thing with the count. Check to see if the scene triggers count is less than or equal to 0, or better yet, check to see if it's less than or equal than your trigger, because even if there are triggers, you want to make sure that it lines up with the one that you're looking for. So I just left it as 0, but this should actually really be trigger. And then you could throw a new exception there. Next, we're going to use a little funky C# syntax here, and we're going to do an if statement, and we're going to check to see if the scene trigger is not equal to null. So what we're going to do is we're going to do scene triggers dot first or default. And then we're going to check to see if our scene trigger dot current level trigger is equal to our trigger parameter. And we're going to make sure we cast everything correctly here. So basically what we're checking to see is, can we find the trigger we're looking for? If not, we'll throw an exception, say that it's missing. But the is not and then scene trigger class with that variable also defines it so that we can use it after this if statement. Finally, do a game manager dot get player dot position, and then we're going to make that equal to our scene trigger position. But now remember, we have to move the player so he's not just constantly switching between scenes. So we're going to do scene trigger position plus the scene trigger dot entry direction multiplied by our grid size from globals where we declared it. And that's all we need for our switching function. So now go back up to your change level function and check to see if spawn is equal to true. We're going to do an instance.spawn. Otherwise, do an instance.switch and pass in the trigger. After that if block, you can do an await instance.fadeIn. So once we've switched position and we're ready to go, fade the level back in. And then finally, set is changing equal to false. Let's go back to Godot and go to our project settings. Inside of our globals, we're going to add the scene trigger scene instead of the class. We're going to hit add, make sure it's underneath the globals. That way we can automatically load it when the game starts. So let's go ahead and actually just run the game really fast to see what happens. If the scene manager is loading properly, the screen should just be black because we're not really doing anything with it yet. And you can see that it is black and nothing happens. So let's go fill out those to-do statements and change the scene on the start, and then see what modifications we have to make this work. So inside of our game manager function, we're going to do a scene manager.change level, and we're going to set the spawn variable equal to true. That will start the game and change the level for us right away. We don't have any level loaded by default, so we do need to do this in order to start. Inside of the onBodyEntered function, inside of our scene trigger class, you're going to do a scene manager.changeLevel, but this time you're going to pass in the level name and the trigger. And those are going to be your target level name, and the trigger is going to be the target level trigger. Now, if you hit play again, what's going to happen is you should get an error message inside of your debugger, and that might be for a few reasons. I suspect it's because we never added our fade color rect to the actual class, like we didn't assign it inside of the inspector, so we're definitely going to have to do that. And I also think we forgot to actually call the getLevel function from our changeLevel function, so we're not actually loading the level. So let's go fix that too. And now that we've awaited the instance.getLevel, let's go ahead and run the game again and see what happens. Okay, so a few things here. The game actually loads, so that is some progress. I see 81 calls here to my debugger, so I already know that this is something to do with the tile map. And it's probably because when I auto-assign the tiles, you didn't see it when I was doing my montage, but sometimes they're out of bounds a little bit, so we can fix that after. But let's just go through it and make sure everything else works first. So first and foremost, when you see me walk into this door here, nothing happens. And that's because I haven't told my game or my character movement how I want to interact with a scene change or a scene trigger. Because it has a collider right now, it's just assuming that there's a collision and won't let me enter it. So what we're going to do is we're going to make a case for our scene trigger class. Inside of my isTargetOccupied, you remember where we put the tile map layer is equal to true. We're going to make a case for our scene trigger, and we're going to make this pointing to false, so that if we hit a scene trigger, don't have a collision and let us walk into it. Let's try and hit the scene trigger and see what happens. So the scene trigger fires off, but now you can see everything looks a little weird, and I think that's because we forgot to remove the old game level. So let's go ahead and take a look at the code and see if we can't straighten this little error out. Yes, inside of the getLevel function, inside of the first block, after we fade out, we have to get the game viewport and remove the child. So remove child, current level, and that should fix this little problem. So I walk into the house, and it looks like the scene is changing. And you can see the camera bouncing around, and that's because we have position smoothing on. I'm actually going to go to my player class, my camera 2D, and turn off position smoothing. I don't like the way this looks. And now when I enter the scene, the next scene, you can see that the camera follows me around. It doesn't really bounce around, so that's good. And I'm just going to check out all my houses here and all my scene triggers and make sure I have them lined up properly. So I have 0 pointing to 0, 1 pointing to 1, etc. Okay, so you can see there's a problem with one of my cave triggers, and one of them's not working because I probably didn't define it correctly, so I got to go back and fix those. So I'm going to go through my scene triggers and make sure they all line up. They all have the proper target level names. And I'm going to double check my scenes and make sure that the level class has the proper scenes selected for the level name. So I had to fix the one in the cave, and I'll go back and check the other ones as well. Okay, all of the scene triggers inside of the cave look good. They're all pointing to the small town. So let's go back and try that one more time. So the entrances line up now, but you'll see I get this weird movement where I kind of just move across the screen here. And what that's happening from is when the scene switches, I have my hand pushed down on moving, and he starts moving before any of the collision detection happens. So it kind of bugs out a little bit. So there is a way to fix that as well. And basically inside of our player movement, or our input, we're going to disable the input if the scene manager is changing. So we just have a couple more things to clean up here. First, let's fix the tile map errors because I want to get that out of the way because I hate those debugging messages. If you load a tile map, you'll see here there's a little warning, and that'll just basically tell you that some tiles are out of bounds and give you a quick way to fix it. And you're going to want to hit the 3 little dots and do the remove tiles outside of the texture. And so now when I do that and I load the game, you can see that I don't get these error messages anymore. So that's one problem fixed. Next, we're going to create our player camera script. So we're going to attach that to our camera 2D. And what the purpose of this script is going to be is to set up the limits of the level. We're going to grab those from the current level. And because the scene manager is a singleton, we can grab those variables pretty easily now. So inside of the new player camera class that you create, you're going to have an export category. I'm just going to call it camera vars. And we're just going to have one variable. It's going to be our public level, current level. And this is going to be assigned automatically for us, so we don't have to assign it in the inspector. And what we're going to want to do is use the current level to update our camera limits. So I'm actually going to create a function called public void update camera limits, and I'm going to set my limit top equal to my current level dot top, and do the same thing with bottom, left, and right. Once I do that, inside of my process, I'm going to check to see that if the current level is not equal to the scene manager's instance current level, I'm going to update my current level and then call my update camera limits function. And then you can copy and paste this into your ready function as well, so you can call it right when the player camera turns on. This function will always have a current level to call because the player won't get instantiated until there is at least one level or current level is not equal to null. So now when you do that, you can go ahead and test your project one more time. And if you start walking around towards the edges of the map, you'll notice that the camera won't go out of bounds anymore. So you don't see that gray. You only see the tree limit of whatever your limits are that you define. So I defined mine at the edge of my different tile maps. So you should do the same. And now finally, let's go fix that problem where if you're holding down the button next to a collider, the player kind of glitches out. I'm just going to go to my start walking function inside of my character movement. I'm going to check to see that if the scene manager is changing, we just want to return. So don't even go through this function. Don't do anything. If the scene manager is changing, just quit. And now when I hold down the key outside of my little cave entrance here, I don't go flying anymore. So everything seems to be working properly. And I think this is a good stopping point for this video, as we have successfully added our scene manager, and changing the scene seems to work once you line up all your variables and all your scene triggers, and the player can't move when you're changing scenes when it's fading in and out. So I think this is a good stopping point. Okay guys, thank you so much for tuning into this video. I think in the next video, we're going to take a look at ledge jumping because there's a couple little extra things we have to do with colliders there, and having its own video for it is a good idea. Okay guys, thank you so much for tuning back in. If you liked the series so far, don't forget to like, subscribe, and if you're feeling real generous, you can buy a coffee to support the channel. Okay guys, thank you so much, and we'll see you in the next one.